So far, every question we've looked at in sampling theory to do with the central limit theorem, we've been told what the population mean and the population variance are. Bit of notation first of all. Population mean, what symbol have we used for the population mean? Mu. What symbol have we used for the population variance? Sigma squared. Yes. Okay. If we don't know mu, is there anything you think we could use in its place? Let's just go to a scenario where this may happen. Maybe, big tree out there, we are trying to work out the parameter, about that tree. We've taken a sample of maybe 50 leaves from that tree. We clearly don't know what mu is. We haven't measured every tree. What could we use?
X bar.
Yeah, we use X bar to estimate it. That's right, okay. You use X bar, which is the sample mean, to estimate an unknown mu. And X bar here in this case is called an unbiased estimator. And I'll give you a definition of that in a minute. An unbiased estimator because, and I think we did this before, the expected value of X bar is mu. In the long run, if you averaged X bar, you would get mu. And that's the definition of an unbiased estimator of something. If its expectation is the thing it's trying to estimate, it is an unbiased estimator. So X bar is an unbiased estimator for mu. Sometimes you'll see this symbol here, mu hat. With that little hat, that hat symbol is implying that it is an unbiased estimator. So, we know what mu hat is. What we need to know next is what sigma squared hat is. What will be our unbiased estimator for the population variance? It is this.
Is that a hat?
That's a hat.
No, I mean when it starts to go flashing.
That's an N. Okay? This is our unbiased estimator for the population variance. Does any of that at all look familiar?
If you're going to say sigma squared hat, is it that way around or is it sigma hat squared?
I honestly don't think it makes a difference. I would say sigma squared hat. Okay? That's just how I say it. I'm not saying that's right, but that's how I will say it, sigma squared hat. So, does any of that look familiar?
Yeah.
Why and which?
Series. Yeah. Oh, is that
That's a thing.
Well, yeah, what's this over here?
sample variance?
Yeah, that is a sample variance there. That is a sample variance. And the sample variance I'm going to denote as S squared for the sample variance. So the sample variance is equal to that. So that's saying that an unbiased estimator for the variance is n over n minus 1. It's like a little fiddle factor, S squared.
So,
Just go on.
is that the expectation squared, or is that
That's a big sigma there. Sum of, yeah.
So yeah, sum of
X squared.
or is it the sum of x squared?
It's the sum of x squared,
Okay.
not the sum of x squared. Okay? So, this down here is our unbiased estimator for the variance. I'm not at the moment going to derive that for you because it is extremely complicated and you haven't got to be able to do it. But if you want to see the derivation of that, it is in the books, in your textbooks. But what you need to be able to do is to use that. There is a reason for this n minus 1 thing. And if you've got calculators, on your calculators, you may already have come across a button on your calculator, sigma n, to work out the standard deviation from a list of numbers. You'll probably also find on your calculator sigma n minus 1. There's a little n minus 1 there as well. And this n minus 1 is this one here, it's that. It's this fiddle factor here in there as well. So I'm going to pause it now just to see if you can see on your calculators where you can find both of those things.